In this video, I'll be showing off the major features available in the on-prem version of FusionReactor. FusionReactor provides you with real-time application performance monitoring, combined with application, system and database performance data. Using FusionReactor, you can quickly investigate and pinpoint issues and performance bottlenecks. FusionReactor on-premise allows you to not send any metric data outside of your organization. It will only store data locally on your server. It's worth noting that FusionReactor provides the capability to obfuscate data. This can be obfuscated either locally or before being sent to the cloud. On-premise is ideal for those running monolithic applications and is often preferred by governments, education, healthcare, and verticals where security is paramount. The Enterprise dashboard is only available in FusionReactor Enterprise Edition or higher. The globe icon at the top left is used to access this feature. The Enterprise dashboard is a powerful tool providing an overview of your infrastructure from one location. You can monitor the state of group and individual instances and set thresholds for instances to enter a warning or error state based on the resource usage. Any FusionReactor Enterprise Edition installation is able to report the state of the server remotely to any other FR Enterprise Edition server. You can immediately see the state of memory, CPU, database load and average request time in an easy-to-read graphical dashboard display that you can also find on the server's own metrics page, on which you can gauge the general health of each server. Using the ephemeral data service, you also have the ability to proxy the FusionReactor user interface, allowing you to access the local FusionReactor instance without having an exposed port. Manage servers will let you add new servers to monitor or edit the details of existing ones. Manage groups allows you to configure groups that servers can be added to. Settings lets you configure your preferences for the Enterprise dashboard. Now on our server with FusionReactor we can cover metrics. Start by clicking Metrics, Web Metrics. The Web Metrics screen presents the data recorded by FusionReactor related to your application server and its request load in a curated, useful and easy to analyze structure. You can change this view to last hour and clicking into a singular graph, creating a large version of the selected graph, which can show up to 1 week. In the Overview table, you're provided with general statistics about the application server, such as server uptime, which tells you how long the server has been active for, and the average request time a request is taken to be processed. The Counts table provides numbers on the state of web requests and JDBC requests by your application server within the last 60 seconds. Bear in mind the number of historical requests stored is set to 100 by default, but this can be increased if your server is particularly busy. The Recent table shows information about recent web requests and JDBC requests, recent meaning any requests within the last minute. The Protection table displays the statistics of the crash protection triggers, revealing the type of protection that caused the trigger. We'll take a look at crash protection later. The Return Code table lists all HTTP codes which have been returned by this application server. Each return code is also a link which will also show you all requests from the count request history which have that return code. The Requests History page shows a list of the most recently completed web requests. The number of historical requests stored is configurable and the default is set to 100. All the request information is stored in memory. As new requests enter the list, older requests are removed. Here you can see roughly what's going on with 3 time columns: total time, database time, and API time, aka Cold Fusion HTTP calls. As this shows the last 100, the history depends on how busy the server is. Selecting requests, slow requests, displays a list of all slow running and slow finish transactions, which have taken longer to run than the current slow request threshold, which is set to 8 seconds. If the time is all in the database, you can click and expand next to the timestamp to show which queries took all the time. You can click the book icon to look into the request further and get more details. On the right, we can see JDBC queries and their average time. But how many queries did the request involve? The JDBC tab gives us a breakdown and shows the slowest 30 queries. This can help us identify if a query is optimized or if it's the volume of queries taking up the time. If you click the Relations tab, it shows where the time has gone during the transaction. As we can see here, the vast amount of time was spent on web requests and the CF HTTP calls that our transaction made. After a transaction runs for more than 3 seconds, the profiler kicks in. You can click this tab and it breaks down the time spent by the request in percentages, so it fills in the gaps of request that were not database or API calls. Overall here, you can get the details of what's going on with a request, whether it's in JDBC, Relations, or Profiler. Now for requests and the error history. On an example request here, you can expand it to show where the time went. If an error was detected, the details of this will be displayed in the Error Details tab. This is a similar view as the request page, but Error Details gives the stack trace of the error. With a recurring error, you can click on Event Snapshot. The Event Snapshot displays source code, scope variables, stack trace and login information at the point the problem occurs, providing everything you need to isolate the issue as quickly and efficiently as possible. It fills in the gap between simple error tracking with stack trace and the full interactive debugger, which allows step-through control within your code and the ability to modify variables. The production debugger provides insight into how code executes at production runtime and includes a rich IDE-style debugger which is completely built into FusionReactor and allows breakpoints to be set. Also variables to be modified during runtime, code decompilation and stack traversing, as well as a breakpoint email alerting which consists of an email being generated whenever a breakpoint fires. The Resources tab allows you to visualize the instance's memory, CPU, garbage collection, threads and more. Because of its visual nature, the graphs can very quickly give you a good idea of how the system is performing, and because they can cover larger periods of time, they can warn you of trends which could become a problem in the future. You can also manually start a garbage collection on this screen by clicking the Garbage Collection button. Now for requests and applications. This is a high-level view. Apps are shown on the drop-down in the top right, and application names are fetched from the application.cfc file by default. This view shows the average runtime, page hits, etc. per application, and can be set to show for the last 10 minutes, 30 minutes, hour, or since the start of the server. Similarly, there is the JDBC databases view. This view is the same concept as applications, but you can select and show what you're doing with your databases. So overall here, you can go higher level with the information, as well as the very detailed views we've seen. FusionReactor also provides you with a feature of email alerting. The email alerting feature is useful for unattended monitoring via protection and is a way to protect your server from various types of load. You can set up your SMTP server into FusionReactor settings for FusionReactor to send email alerts. Under protection and settings, you can set up crash protection based on your needs and your environment. You have the ability to configure these options to restrict how many requests can run on your server at any one time, and to protect from excessive numbers of requests being run, which may cause your server performance to become slow or even crash. Under quantity, you can adjust the request threshold, so for example you may wish to be alerted when 20 requests or more are running simultaneously for 30 seconds or more. Runtime refers to a single request, so you can define at what point is too slow for your environment. For example, if a request were to run over 60 seconds, this would send an alert. If you have requests that you know will always take a long time and you wish for FusionReactor to ignore them, then you can go back to Requests and History, and next to the Details button is an Ignore button. Clicking this will add a crash protection rule, and it will auto-complete the rule for you. So all you need to do is click Add. Now FusionReactor will ignore this when it comes to alerting you for crash protection. You can also add custom rules here and make it generic to the CFC file if you prefer. These can be found under Protection Restrictions. There is also memory and CPU protection, if those are things you are currently concerned about in your environment. The Log Archive Viewer is used to visualize the log archives which are generated by FusionReactor. The Date and Time Picker are used to navigate through time and visualize log file contents at those points in time. When entering the page through the menu, the date will automatically default to today and render the most recent archive file contents. The File Picker is how the user navigates between different log files in the archive. Log files are split up into different logical categories, such as resources, requests, and memory. There's a search box at the top of the file section, which will open the category the file is found in if it is found for that rotation. So overall, FusionReactor provides detailed information about your application's performance, including memory and CPU usage, slow request analysis, and more. Installing FusionReactor helps improve the stability, reliability, and performance of your Java applications, making sure they meet the demands of your users.